Okay, I'm back at it again, and as I said earlier, it's going to work on wiring up the B plus and the cake pan. So refresh everybody again. These particular capacitors right here are 2-in-1. They're two individual capacitors built together in one enclosure. They have a common ground wire in the back, just one single ground coming out of the back like so. So you can use them in some applications, and some applications you cannot. This is rated at 16 UF, 16 UF, so they're both equal size capacitors, 500 volt, and these are F&Ts. They're really good transparent tone. This one's the same thing. It's just the label on this one's towards the downside, like I said earlier. This one's an F&T 16 UF 475 instead of 500. It's a single cap by itself. There again, talked about earlier. Here's your swelled end of your cap that indicates the positive polarity. You can see the positive signs right here. Doot, 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 doot. Right there. Doot, doot. And some more be underneath there. Some more doot, doot, doos underneath there. Anyhow. So what I've got is I come in with my power cord. Go through the AC switch, which powers up the transformer itself. Once the power to the transformer is powered up, remember this is AC in, AC out, just like I talked about in the last one. So this is my secondary, this is my primary, this is 120 volts. This side's got my individual coils. This drawing, by the way, is Leo's original drawing from, I don't know what year he made this one. There's no reference to it that I can see. This is for Deluxe Reverb double A763, which is the same as a AB763. There's very little difference between the two for what I'm doing on this. Putting out roughly 330 volts on my secondary on this set of coils right here. This set of coils right here is similar to the one that I showed you yesterday. Let's see if I can get to it again. This is a classic tone. Here's my 120 primary, my stacked laminations. Electricity makes magnetism. Magnetism flows backwards, makes electricity. So here's my HT, which is this two reds across here. These two reds, if you measure across the voltmeter, AC in, AC out, remember, it's going to give me 650 volts. If I go from the red to the red-yellow center tap, it's going to be just exactly half, 325 from here to here, 325 from here to here, and embedded in a shorter section of this winding is the red and green, which is the 50 volt bias tap. This is the classic tone. This replicates most everything that I'm trying to do to match up to the original AB763, which is back here. Oop, one too many. Nothing up my sleeve. Presto! Get my pointer down here where I can see it. Same basic thing right here. Between this wire and this wire would be 660 volts. Mine's 650. Here's my center tap. So if I measure from here to here, it's 330. Mine is 325 because mine's rated at 650 instead of 660. And here's my bias tap coming off right here to go into my biased section right here. So if you take a look at the rectifier tube, this is GZ34. That's the Euro designation. American designation is shit, my brain went blank. AR4. Exact same tube, just difference between if it's made in Europe, it's made in the USA. So I'm coming off of here with my voltage. This is still AC. Comes up here, hits the standby switch. And at this point right here is where I am converting this to DC right here, going through this rectifier tube. I said AC, didn't I? This is DC after it goes through AC on this side, DC going out because it's going through the rectifier tube, going up through here. These two 16 UF capacitors that are wired in parallel become my reservoir filter cap, which goes to my standby switch. So I've got on my rectifier socket that I've got inside of here wired, I've got a yellow wire that comes up to the standby switch. Yellow wire comes up. These two right here are housed in the cake pan. These two are this 2-in-1 capacitor right here. 16 UF, 16 UF. They're bridged together right here, so they're in parallel, and the ass end's already bridged together internally back here. And here's my yellow wire right here. At this point, I'm on DC voltage now because I made DC at the rectifier tube, and this reservoir cap maintains a steady DC voltage supply leaving on this yellow wire, which goes to standby switch. Now from the standby switch, I'm going to come over here. TR2 is my choke. So I've got DC volts, and it says right here I should have roughly 420 volts DC. So 420 goes to 1/2 of my choke. The other 420 goes up to the center tap on my output transformer right here. This is the OT-CT, which is output transformer center tap right here. Goes through this winding, goes over here. Here's the plate on this 6V6 GT. Goes this way, goes through this winding, comes over here. And here's the plate on this 6V6 GT right here. There again, there's my laminations. Here again, this is my secondary side, which goes out to my speaker cabinet right here. So at this point right here, I should have 420 volts. If I come back right here and the switch is closed, this standby switch is closed right here. At this point here, I should measure roughly 420 volts when it's energized. Then I'm going to go through my choke right here, which minutely drops the voltage a little bit. And the reason for this choke is it drops the voltage to be able to feed your screen resistors. The choke it's more efficient than a straight dropping resistor is right here. It helps take out a lot of the ripple effect also that you get when you convert AC into DC. Because when you convert AC to DC, you're clipping off the top of the sine waves to make a flat line. Once it goes through here, I'm dropping roughly 5 volts at this junction point right here. Coming up, this is my screen resistor for this 6V6. This is my screen resistor for this 6V6. And I should be plus or minus right around 415 volts right here. This has to have a capacitor right here to help with the ripple effect because I've dropped voltage from this point to this point. I've dropped 5 volts, 420 down to 415. So this capacitor right here, this 16 is this single capacitor right here. I've got a fly or a bee somewhere. Yep, don't sound like a bee. So anyhow, and the reason for your screens to be slightly less than your plates is as your cathode right here is boiling off electrodes to be sent from the negative charge cathode to your positive charge plate. The screen resistor aids in having the electrons flow this direction easier, but you don't want it the same potential as this, because if you do, then the electrons tend to stop right here at this plate, this screen, and not get to the plate. That's what I was trying to say. Electron boiling off. Here's your grid coming in right here. Goes through the grid, attracted this way, but continues on because this is more positive than what this is by 5 volts, 420, 415. Now I'm going to go across a 10K resistor, and I'm going to drop the voltage again. I want to drop the voltage again. I need another capacitor to take the ripple out from just dropping this across right here. C right here indicates that C right here is going to be picked up. This C right here is my phase inverter. So my phase inverter is going to be plus or minus 325 volts. That's how much I dropped on this 10K resistor. 415 down to 325 plus or minus. That is, I was at 415. And if I could roll it around far enough, you would see it. This says 10K 3 watt. I can't quite read it. These are Dale resistors. Very good quality resistors, made in Mexico, but somebody down there is doing something right because they work really good. 415 goes through here. 1/2 of this capacitor right here, remember it's dual capacitor right here. 1/2 at 16 UF, which is right here, 16 UF. Takes that ripple out of there again at this node right here. These are all B pluses right here. At this node, I should measure plus or minus 325 volts. Then it's going to drop for the final time right here through this 10K resistor to this node right here. That is 10K right here. I'm at C at 325. Go through this 10K right here to D. Again, I've got one last 16 UF to take the ripple out again. D comes over and feeds all of the preamp itself. And it doesn't say it on this print, but it's roughly somewhere around 275 volts. If I do this, I don't know if I can see anywhere where it says 275 on here or not. This D right here, that's 275 volts, 275 volts. Over here, in very small, hard to read, this is my phase inverter. That's 325 volts right here. Down here, I have a, let me catch up with my pencil here. Right here, I've got the turret. This is 415 volts. This is for that hole right there, indicates a hole in the chassis. This goes through the other side. This is my reverb driver right here. And over here, utilizing, all they're doing is just having some turrets here for junction points, being able to junction this together. So I'm coming from a rectifier, GZ34 or 5AR4, if you're using American version. I'm coming up here with this wire. It goes from here up through to the cake pan to this right here. 1616. At the same time, it comes down to the standby switch. You flip the standby switch on, it goes from the standby switch, goes up here to these turrets right here. These turrets right here, that red wire is the output transformer center tap. This black wire right here is the choke, goes down to the choke, comes back from the choke. Here's a couple turrets for a junction point, 415 volts. Excuse me. Goes up to the cake pan. Right here, 415 volts. Then it drops 10K, drops 10K, And of course there's capacitor here and capacitor there. That's pretty much your B+.